All right, thank you all for making it to class on time. Um, eh, Kind of a busy day, but after the lull last week, but we're grinding to the end, so that's okay, right? So, uh, okay, 1 second while I let another student in. So we're up to section 12, and we're going to hit what's known as DML on the SQL side, data manipulation language. Basically, you're changing data within your tables, or you have the opportunity to do that. This is Barry Whitfield. I don't know that name. Um, hmm. Well, someone's in the waiting room that I don't know who they are. Oh, it must be Kevin. All right. Whitfield. All right. So DML, we're gonna go into our first part of DML, and that's insert statements or inserting data into your tables. And then 12.2 is updating column values. So it's updating and deleting rows or records. And then 12.3 is default values, the merge command, and multi-table inserts. So a lot to learn today. So stand by. And then there's a section in here, basically on the particular components of SQL, DML, DDL, DCL. I'm going to review database commands briefly, and then just point out the practices, videos and demo practices. And then you have an assignment this week and a quiz. So back to normal. And then the due date is the 10th. Well, the good thing, next Monday is Veterans Day. So technically it will be, well, it is for us. It's going to be a day off. It's a holiday. So the good thing about that, yes, I'm a veteran too. So, make sure you thank all the veterans out there. So there will be no class meeting, and there's no assignments due that week. So that's a good thing. No class, no assignments. So you basically get a little vacation, another vacation for some of you. We start up again on the 18th. And I will bombard you with work. We're going to hit sections 13 and 14, but it's not so bad. Meaning that I think within those two sections, you only have one quiz and one small assignment, so it's not that. So, but anyway, next week we will not meet, no class, and you don't have assignments. But remember, section 12, the due date is that Sunday. All right. So let me bring over our section. All right, so on to section 12 we go, DML. Now we get a chance to manipulate the data. So let's get into our slides. My computer's running a little slow. Yeah, you can do it. All right, there we go. All right, so section 12, topic 1, insert statement or objectives. Explain the importance of being able to, or explain the importance of altering data in the database. Construct and execute an insert statement, which inserts a single row using a values clause, and you'll see that. And construct and execute an insert statement that uses special values, null values, and date values, excuse me. Construct and execute an insert statement that copies rows from one table to another using a subquery. Yeah, very useful. I've used that a lot. So let's get into it. All right. So here we go. Insert statement, kind of the first I guess, substantial statement to use with SQL as far as manipulating data. So up to now, we've been learning how to access data. So it's time to learn how to make changes to the data in your database. In business, databases are dynamic. There's constant changes, and there's not really anything that can be called static data. And it's interesting now, just to explain a little bit or expand the explanation a little bit, all of these front-end forms and websites, they're all hitting a data, they're all running queries that are constantly updating the data in the database. So that's one thing you should be aware of. Let's see. Trying to make sure I have everyone. So that's where we're going now. So think how many times a school student's database changes from day to day, year to year. Unless changes are made, the database would quickly lose its usefulness. Well, that's not going to happen. So in this lesson, we're going to learn about data manipulation language, another aspect of SQL. And it's basically that, you're manipulating data. All right, copy tables before inserting. So although we used to have to do this, I may eliminate this slide. We're not going to, there's really no need to copy data because we're not using a shared schema. And you can always run the original query if you ever have a problem to reset your data. So we're not going to copy tables, so don't worry about that. Matter of fact, I'm going to shoot right through these slides. You can go back to them if you feel like you need to copy your data or make copies of your tables. But I'm telling you right now, it's not a big deal because we used to use a shared instance, but now we have, because of the cloud, now you all have your own instance and you can do whatever you like. All right, right into the insert statement. The insert statement is used to add a new row or record to your table. The statement requires three values: the name of the table, the name of the columns in the table to populate, and corresponding values for each column. So how can we insert the data below to create a new department in the departments table? So basically our first scenario, we're trying to create a new department, and that department is going to be 200 human resources. The manager ID is going to be 205. The location is going to be 1500. So if you take a look at this query, this is the syntax. Please be aware of the syntax. The statement explicitly lists each column. See here, you have first our table. And yes, this can be annoying. I'll have to change the slides. The copy departments is the departments table. So once again, please, you don't really need to copy your tables. Department ID, department name, manager ID, and location ID. And then we have our values clause. And the values are enclosed in parentheses. Remember, numbers are standalone. String or text are enclosed within single quotes. And basically, if we ran this query, which let's go ahead and pause and run this query to insert into departments. And leave our column names enclosed in parentheses, department ID, department name, and I'll pull this query over. Manager ID and location ID. Parentheses, and then it's values. The values clause, and then you place your values. All right, 200, separated by commas, human resources, manager ID 205, location ID 1500. in the semicolon. So if you take that, but first, before we do that, let's just look at our departments table so we can compare. Select star from departments. It's always a good idea to do something like this just to check to make sure. So we see we have 8 departments, 10, 20, 50, 60, 80, 90, 110, and 190, and manager ID, etc. So we're going to insert a new department. So on that, it'll just basically, oh, missing a comma somewhere. Oh, oops. That one. There's a period there instead of a comma. Yeah. So here, one row is inserted, right? We all see that. And if we go back to our departments, we'll see that now we have a new department. And notice the way the database runs, we're not ordering it. So it's the first, it's always the first, well, typically in this scenario, it's the first record in our database, right? That's our new department, right? So if you don't make a mistake like me and put a period instead of a comma, and then that's how you insert records, as simple as that. Now, you have to be aware, and I know I will go into this, about the columns in the table and the order, et cetera, and the data type, all of that. So another way to insert values in a table is to implicitly add them. And implicitly, basically, the system is assuming if you don't list the column names that you're adding data to all the necessary columns. One precaution, the values for each column must match exactly. If they don't match exactly, usually we'll run into problems. So if we go back to our sample here, and the syntax for implicitly, so insert into departments, and then you put values. And let's run this one. Estate management, 210, 102, and 1700. So I'm going to cheat and just copy this. And we're going to implicit, delete our column names, and 210 state management, right? And the manager ID was 102 and the location ID was 1700. 102 and 1700. So now this is an implicit without, so if we run this, one row inserted, and then if we select our columns, now we have two new departments, state management and human resources. So you see implicitly adding works as well. All right. All right. So, well, did I skip something? Okay. Before inserting data into a table, you must check several table details. So remember that whole describe. Just make sure you do that periodically. If you want to know the structure of the table, the column names, just run a describe in your table. In this case, we're going to describe departments. And this will give you the structure, the columns that are within the table and the ones that absolutely require that cannot be null. So department ID and department name cannot be null. So basically those particular values are required when you're inserting data. Remember that. Okay. And that's what I'm going to refer to now. Notice for the data type. So you do want to take a look at data types. Just make sure you recognize you have numbers here, varchar, which are strings, and then numbers. So matching data types can be a nightmare if you're not paying attention. So remember that. And remember for number data types within your parentheses, essentially, and you'll see the length and things like that, but make sure they're not enclosed in quotes or anything like that. Although this particular system and the compiler and will recognize, and you know, in most cases, and I haven't tried that on Oracle, it will treat it as a number even if you enclose it in quotes, but just be careful with that. Here, it's basically referring to the salary column. It allows numbers with precision of 8 and a scale of 2, which means it's 8 with two decimal points. Let's see, where is it here? Here. And you'll see that in here. And basically, when you run a describe, you can essentially pull in this particular information, but primarily, either way, either describe or just looking at the table data will truly help you to understand the values. All right, just remember that. I mean, there's several ways to make sure you have the right values in as far as your record, your columns, excuse me. So inserting rows with null values, yes, you can do that. Insert statement needs to not specify every column. The nullable columns must be excluded. So if you look back on our little example here, the only columns in the departments table that can be null are manager ID and location ID. So you can insert values, run an insert without providing data for those two columns. And just remember that. If you do not provide data for a not null column, you'll get an error message. Basically, it cannot insert null into, whatever the column is. That column is said not null. Yeah, you'll get an error message like this. So you do have to provide a value. All right. So an implicit insert, if you forget to add a value for those nullable columns, it'll insert nulls. So if we added another department and did not provide the manager ID and location ID in that example, it will automatically add nulls to those columns, which is not a good idea. So in this example here, basically it does produce a scenario where you'll probably have missing data that will need to be updated. In real life, nulls are really not, and they're frowned upon. So be very careful with that. So generally you want to be efficient in adding your data, make sure. And if you're running something or checking or troubleshooting something where there's a problem, usually there's a shift or someone had entered something in wrong or things of that nature. I've gone through all that. All right, inserting special values. Special values such as sysdate and user can be entered in the values list of an insert statement. So sysdate, just the current date, and user is the current user. So you can use that if you have a date column and you just want to enter in the current date for some reason, yes, you can, or user. And with our systems now, you are the user of your schema, etc. And generally, I guess, well, for the most part, I mean, unless there's security issues, I think, I'm actually not sure what actually is displayed or written to the data. We would have to run an example on that from this Oracle scenario. But yes, sysdate and user can be added in your values. Inserting specific dates. Remember the default date format is day, month, year with the 4-digit year, 2-digit date, 3-letter month. With this date format, the default time is midnight. So in an earlier section, we talked about 2char. If you want to change the date format, you want to use the 2char and set the format. Generally, unless there's a database that's tied to specific display, you don't really worry about the data format because you can reformat it on once it's produced as an output. So, but this is a good example of changing it so it's a certain format. Oops. I'm skipping. Where am I? All right. Similarly, if we want to insert a row with a non-default format so the same thing. Basically, if you want to use a to-date, remember the format there, and then your formatting characters and all that, just go back to that. So, and this is just producing a specific date time format if you needed to do that. If you want to do that or have it written other than the default, generally you don't do that. In my experience, it's always the default is fine. You just convert the default if you need to select the data. All right, you can use a subquery. You all know what subqueries are now to copy rows. Each insert statement we've seen so far has only one row, but suppose we wanted to copy 100 rows from one table to another. So we do not want to have to write and execute 100 separate insert statements. So that, as obviously would be time consuming, SQL allows you to use subqueries within an insert statement. All the results from the subquery are inserted into the table. So we can copy 100 rows, 1,000 rows with one multiple row subquery within the insert. So as you expect, you don't need a values clause when using a subquery to copy rows because inserted values will be exactly the values returned by the subquery. So if you take a look at this example, insert into sales reps, and we don't have that tape, but ID, name, salary, commission percentage, select, and then you immediately place the subquery, select employee ID, last name, and notice that these columns have to match have to match data types and have to be the number of columns from employees where job ID, basically we're looking for reps. So the syntax again, insert into your table and your columns explicitly or implicitly, but be very careful with the implicit. And then you just follow it with a subquery select statement. And the system will read that, read all of that data that matches your where clause into this particular sales rep table. And generally, and you'll see later, you can create a table and then just write specific data if you want to do that. Even if you wanted to copy data, excuse me, another student in. You can do it that way as well. Just an insert into, as long as everything matches. Remember, everything has to match. So the number so once again, this just illustrates the number of columns has to match. If they don't match, then you can run into issues using the subquery. That's why you just have to pay attention. So if you wanted to copy all data and all rows and all columns, the syntax is even simpler. You just use insert into sales rep and then select star and use the wildcard. It will copy everything, including all the columns. So this is a good way to copy a table. You'd have to create the table first, but if you wanted to add all the data to that table. And remember, they have to have the same number of columns, et cetera, et cetera. All right. So that's the insert statement in a nutshell. You had insert into, you had insert with values, you had the implicit columns and the explicit columns, and you had the subquery. We didn't talk about transaction, but But to insert, and you'll see here as you go through the assignment criteria, yeah, you'll get an intuition about how that works. Any questions about insert? Pretty straightforward, right? So now you can play with the data, add things to your tables, take things away. But anyway, just be very careful. All right, so for topic 2, we're going to go into updating. So updating column values and deleting rows. Be very careful when you're deleting. That can be, and even updating. I always tell students about my story of updating raises to certain employees, and I ended up giving everyone in several departments a raise when they weren't supposed to. And it was a simple update clause that I had to run. I had to run it manually because the forms were down anyway. So be very careful with updates. So objectives in topic 2, construct and execute an update statement, construct and execute a delete statement, construct and execute queries that use a subquery to update and delete. Once again, if you're using subqueries, be very careful. Always test your subquery first before you add it to one of these DML statements. That's another very good thing to practice, because then you have expectations of what actually will happen. Construct and execute a query that uses a correlated subquery. Remember those, update and delete from a table. That can be a little tricky, but you really need to be in control. Explain how foreign key and primary key integration constraints affect update and delete, and we'll talk about that. Explain the purpose of for update clause in a select statement. All good stuff. All right. Okay. All right, so the purpose, wouldn't it be wonderful? Would it be a wonderful world? Yeah. If once you got something done, it never needed to be changed or redone. We all know that that's never going to happen. That your bed would stay made, your clothes would stay clean, and you would always be getting passing grades. Unfortunately, in database, as in life, there's nothing permanent except change. Yeah, cliched, but that is true. Updating, inserting, deleting, and managing data is a DBA's job. And yes, I was a DBA for 5 years, and that's all I did. Building schemas, updating tables, changing passwords, all of it. That was my job. So in this lesson, you'll become a DBA of your own schema and learn how to manage your data. I know that makes you all excited. Now you have the database administrator title. All right, the update statement. The update statement is very powerful, can do a lot of good. As I said, I mentioned my story about updating, giving everyone at the university some 20, how many was it? Oh, some 2,500 individuals got raises that they weren't expecting, but oh well. The update statement is used to modify existing rows. Update requires 4 values: the name of the table, the name of the column or columns whose values will be modified, a new value for each column or columns being modified, and a condition, yes, a condition that identify which rows in the table will be modified. That's pretty important, because if you don't add the condition, then what will happen? Every row gets modified, right? I know of another scenario where a gentleman was just tasked, it wasn't me, but he was just tasked to update someone's maiden name to their married name. And it was a very unique name, but they ended up updating everyone's name in the department. It was like 20 people all had the same name. We thought, wow, that's a big family. But anyway, so the condition or the where clause in these update statements is very important. The new value of the column can be a result of single row subquery. Yeah, subqueries can be useful as long as I will keep saying this, as long as you're testing that subquery first before you're running it. So here's the general syntax or an example of an update statement. So you have update, set, and where. Please always use that. Update your table, set your column equal to a new value, and then where, and then whatever your test condition is. In this case, we're only updating one employee. So This is so important to be very comfortable with that. Because if you're not, then you're going to change a lot of your data and you have to go back and run the schema again to get things back to the way they were, or do a rollback or whatever. But, all right, here's another one. Update employee set phone number equal to this phone number and last name equal to Jones. So we're changing two columns here, right? And it's this one employee. So we're just changing their phone number and changing, well, and then here's an example. So we may have two, that's a very common name, but we want to make sure, in this case, we're updating all the Joneses because I guess we're assuming that they're related. Because our condition is employee ID is greater than or equal to 303. So I would never run anything like that with your comparison, your operator being something like greater than or equal to, unless you're absolutely sure. The update statement and the delete statement as well, you have to be absolutely sure are your records, or are you going to change someone's record inadvertently? And this talks about that. Yeah, if you ever have a name like Jones, you have to set a condition specific to like an employee ID or first name or something. So just be aware of that. Okay, so you can update columns with a value from a subquery. Subqueries, as you see, I mean, the same as in select statements. So you're just looking for the value of that subquery, which may be unknown. So in this case, we're updating the employee, setting salary equal to, and we're finding whatever that value is of the salary. This is a number coming from this subquery for an employee. So we're giving the employee 100, the same, or 101, the same salary as 100. So King, who's the big boss, I guess now Nina Koklar is being promoted. So now they have the same salary. So it's just a subquery, right? Set salary equal to, and then your subquery in parentheses in this scenario. All right. Yep, so we just walked through that. So updating two columns with two subquery statements. So to update several columns in one update statement, it is possible to write multiple single row subqueries, one for each column. So in this example, we're going to update, use the update statement to change salary and job ID for one employee to the same value as employee ID 105. So the syntax is like this: set salary equal to, and you have your subquery in parentheses, and there's a comma. Remember, there's a comma separating the two columns always in SQL. There's always a comma. So that comma right there is very important and it's often forgotten. So salary, job ID, and subquery where employee ID is 206. So can everyone read through that and kind of understand the flow of that using subqueries? Once again, you always need to check your subquery to make sure there's a value produced by the query, because it matches your expected value. Because if you don't do that and it comes back, you may inadvertently change the data, and that's not a good thing. All right. So you can also update rows or records based on another table. As you may expect, a subquery can retrieve information from one table. Well, basically, as long as this query is valid of your schema, you can update your records based on any tables in the database schema. Of course, you have to be very careful what you're doing, and you have to understand the scenario and make sure that your subqueries are returning your expected result. So as you know, there's such thing as correlated subqueries. If you remember what those are, it's a query depending upon a query. These are, once again, they can be complicated. If you don't need to run a correlated subquery, please do not. But you'll be able to practice with those. So In this example, the copy of the department name column was created in the employees table, and data from the original departments table was retrieved, copied, and used to populate the copy of the column in employees table. It just, if you need to do, as a DBA, I never did anything like this because you're setting here, you're ensuring that the data is the same. But if you need to do something like this, I would be very, very careful. We're creating this, we're altering a table. We haven't talked about that. That's going to be in DDL. We're adding this column, department name, varchar, and making sure that it's not null. And then we're updating that table. We're setting that department name equal to, and then whatever department we name it, department name we have coming from the original department. So we're just adding department name to the employees table. Just think of it that way. So once again, make sure you can read through your queries and understand what's occurring. Generally, as a DBA, you're not going to do anything like this unless it's absolutely necessary, because we can easily join those tables, right? And get the department ID based on employees or whatever we need. But in this case, this particular scenario or this particular DBA decided that I want the department name in the employees table. All right. Yeah, so be very careful with correlated subqueries. Generally, a correlated subquery is easily accomplished with a join or a single row subquery, or even a multiple row subquery. Especially when you're updating data, I would recommend, the simplest update scenario is always the best. Once you start complicating, you never know what's going to happen. And I think that's what happened. I don't remember exactly what happened with my race scenario. I think it was a correlated scenario, and I just let it run. All right, enough of that. Now let's talk about delete. Another command or statement that you have to be absolutely very careful with. Matter of fact, I would never run a delete without a where clause, because if you don't, you can possibly, even though it's not a big thing now because it's easily to recover schemas or whatever, but I used to work in at a university where, I had 100,000 tables, et cetera, et cetera. So once again, a delete statement is used to remove existing rows in your table. It requires two values, the name of the table, and then the condition that identifies the rows to be deleted. That's absolutely necessary. You never run a delete without some condition. All right. So in this example, delete from our employees where employee ID is 303. Yes. As a matter of fact, my requirement is never run a delete without a where. Never run a delete without a where. Even if your table only has one row, I still would put a where in there. So we know that this is going to delete all the information on employee ID 303, right? So all of the columns will be deleted. Subqueries and delete, as a DBA, I would steer away from this. Subqueries can be used. So this example here, delete from employees where department ID, and then basically we're deleting everyone that's in shipping. So, yeah, so we're deleting all employees. I guess they all got fired. Oh, well. Or in this case, I'll be positive, the department closed down, so they all got reassigned, right? All right. The example below shows delete the roles of all employees who work for a manager that manages less than 2 employees. See, now you can run something like this. What I would do in scenarios that are a little bit complex, I would just run, instead of running a delete from, I would do a select. Because you can run this as a select statement too, and then delete it, just to make sure you're not bringing anything that might be not a particular part of this scenario. Even though we're using all the particular commands in your subquery. But subqueries are useful if you know the conditions and you're pretty comfortable. And once again, always run the subquery first before you place it in one of these DML statements. All right, moving on, we do have integrity constraints and errors associated with that. And basically they are part of your database to ensure you're not deleting or updating something that you are really not supposed to. Usually a DBA will place these during the schema building process or during the time when the database is actually being built. And they're pretty stringent, well, straight rules that will prevent you from doing something that will cause a huge problem within your database. So for example, violates a not null constraint because, so basically, if you try to update a particular part of your table where it doesn't allow null values and you're trying to write null values, yes, you'll get this particular error message because you're violating a constraint. Not nulls is a big one. With me, I once again, I want to know exactly that table description so I know how to form any of my DML. Remember, DML is impacting the data, so generally these constraints are put in place to protect you. So when will primary key and foreign key constraints be checked? So that's a very good question. The employees table has a foreign key constraint on department ID, as you know that. We join that. We know that basically there's association, there's a relationship. So this ensures that every employee belongs to a department. I mean, as a DBA, you should know that correlation / relationship, because this is why it's called a relational database. And so those constraints are there with that primary key, foreign key relationships, just to make sure, one, you can join and do an explicit join and get the correct information from the join. So which of the following statements, and you can type in the quote or unmute, 1, 2, and 3, which one will produce an error? This is my student engaging phase of the lecture. Which one of these will produce an error? Yeah, answer already. No, Josh says, that's not it. It's just 1, 2, or 3. Which one? All right. 1. Joshua says 1. Anyone agree with that? No, but Bill says 2. Jakrani says 1. So we got 2 for 1 and 1 for 2. So far 1 is winning. We need more. Colby says 1. Anyone else? We need more responders. We only have 4. At least half the class. Oh, Mom says 2. Barry says 1. All right, so looks like it's either going to be 1 or 2. All right. Anyone else? Update. Ryland says 1. I think 1 is going to be our winner. Bill says 1. Employees. Set. Department. ID. Equal to 15. Uh-oh. Where employee ID is equal to 100. All right, that's number 1, right? Did I type that in right? No. So it's always good to have the developer up and running. So this was 1, right? Yeah. So invalid identifier, right? That's not the error we were looking for. All right. Department ID. Update employee, set department ID equal to 15, where employee ID is equal to 100. 100. So that's the error. Is everyone getting the same error? Why are we getting that error? Who can explain why we're getting that error from number one? Anyone? It just simply said invalid identifier. What does that mean like that typing? Okay, department ID. So the best way, if you get something like this, is do a select. Select star from employees where department ID is equal to 15. Right. Does that exist? Yeah. We got no data. So is there a department ID? And then that would be another thing. No, we have a department ID. We do have a department ID in here. We just don't have department ID 15 because we don't have a department ID. Remember our select from departments? We have 10, 20, 50. We don't have a department, or we can even do a select star from employees. So it's always good if you're not quite sure, just check. And if you don't have 15 in the departments table, so yes, in this case, we don't have a department 15. So that's an error. So 1. So we do have a department 10. We know that. And we do have, yeah, 10 and 20, right? So that's why we got that error. All right, good job. So integrity constraints error when modifying your table, you might not see a not null constraint errors, but you will not see any primary key or foreign key constraint errors. I mean, those, and that's the thing too. You'll get something like this where that was primarily an invalid identifier. So you do have to interpret the errors accordingly. So the reason for this is that the create table statement that is used to create the copy, well, okay, so in this case, it's a little bit different. If we would have created tables, the primary key, foreign key does not follow when you create tables. You'd actually have to allocate those. But as a DBA, you wouldn't do that anyway, because you want the copy of the table to not have the constraints. So that goes into the database structure, et cetera. Since we're not going that route, I know that's a little bit convoluted. We're not going to run into, at least for now, any primary key, foreign key constraint errors. And the thing is, you know that for the most part, those particular columns are used to identify a specific record, et cetera. And you really don't want to change those, right? As a DBA, they're either specific values, they're auto-generated, or you manually generate them. And they have to be unique. That's another part of the constraint for update and insert. All right, so the for update clause in the select statement, let's see. So this is when the for update clause is used. As soon as your query is executed, the database will automatically issue exclusive row level locks in all rows returned by your select statement, which will be held until if you use a commit or rollback. So basically it protects the data while the data is being ran. So and this is something that I need to update. In the environment that we used before, everything was shared, so the locks were quite annoying to be honest. But if you can use a for update, and basically it creates a lock so that none of that data can be changed until if you're running a select save until or any type of DML until the query processes are complete. You'll run an example with this, but as I said, with our schema, it's not really necessary. And you do have the commit and rollback. I don't know. Did we talk about commit? Yes, we did talk about it briefly. Basically, it's a way to force a query and rollback if the process is doesn't meet your expectations. All right. So as far as the for update, it is something that once again you probably won't worry about, or you don't need to worry about with these schemas because of the type of database scenario. And this is another one that I'll eliminate. And the next time, during the next time I run this class, we won't have to face that scenario. So anyway, our terminology for topic 2, delete, integrity constraints, update. Remember, update, delete must have a where clause, correlated subqueries for update and correlated subqueries for delete, and then the for update of select. All right, so we satisfied our requirements. We ran through a couple of scenarios. We inserted some records. Let's move on to topic 3 in this section, default values, merge, and multi-table inserts. So our objective is to understand when to specify a default value, construct and execute a merge statement, construct and execute a DML statement using subqueries. We kind of did that already. DML is just update, delete. So this is kind of a repetitive there. Construct and execute multi-table insert. That's very useful, but we know how to do that essentially with a subquery. So let's take a look. All right. So up to now, we've been updating data using a single insert statement or an update statement. It has been relatively easy when adding records one at a time. Well, what if your company is very large and it utilizes a data warehouse? And data warehouse usually has millions of records. So to store sales records, customer payroll, accounting, and personal data, you're talking about millions of records, even multiple millions of records. So in this case, data is probably coming in from multiple sources and being managed by multiple people. And that is definitely the case now. 10 years ago, it was not as big of a deal. Now it's huge. Everyone's doing this. So managing data one record at a time could be very confusing and very time consuming. As a matter of fact, that is not even a consideration anymore. So how do you determine what has been newly inserted or what has been recently changed? Well, I can tell you right now, even when I was a DBA 10 years ago, I kept records of everything as far as DML in the database. And that level of efficiency is necessary. So, but in this lesson, you'll learn more efficient methods of updating and inserting data using sequence of conditional insert and update commands in a single atomic statement. Ooh, atomic, that's pretty substantial. So we also learn how to retrieve data from one single subquery and insert rows, return into more than one target table. So basically, this is just another way, another method to approach, updating data. And usually what you're going to learn now is usually when you have very large databases to deal with as far as the number of records. All right, so each column in the table can have a default value specified for it. And generally, when the table is created, the DBA will indicate a default value. So in the event that a new row is inserted, the default value will appear or will be assigned instead of null. And so if you run an implicit, and usually that occurs insert, then yeah, you can, this is another efficient way. So like, for example, and I think it'll allude to this, if you want to insert a department. So anyway, I don't want to confuse you. So using default values allow you to control where and when the default should be applied. So the default value can be a literal value, an expression, or a SQL function like sysdate and user. I was going to say, if you wanted to insert the system date or your hire date, it's so easy because it'll insert the date, the current date. Or you can even have some type of an expression or calculation. If you want to insert something like a probationary date, which is what I had to do, which was 90 days after the hire date. So anyway, that's what the default value is used for. The default value must match the data type. Excuse me, the default can be specified for a column when the table is created or altered. So generally a DBA will indicate a default value upon table creation, but let's say you wanted to alter the table. So here's an example. As a matter of fact, I've used this before. Here, where their default value, it's a date data type, and the default value for a hire date is sysdate. And there you go. It just indicates it's always going to write that value when you insert a record. First name, last name, sysdate in this my employees table. Okay. All right, so explicit default with insert. Explicit defaults can be used in insert and update statements. So basically, you're explicitly saying that these are the default values. Insert example uses the my employees table, shows the explicit use of default. So default here, the hire date is going to be whatever the default. So you're explicitly telling it to put the value of the sysdate here in that my employees table. Okay. But you can implicitly do the same thing without just have the two columns and then first name, last name. So this is the implicit method. That's the explicit method. So remember that the columns have to match. If you have the columns listed, then the literal values have to match. All right. So there are two methods there. I've used both. So. All right. There's a way to explicitly use default values in an update statement. The update example shows explicit use of default. So update my employees set hire date equal to default. And we know here in that table, the default is sysdate. So is this easier? Say, you can set hire date equal to sysdate. So, so if the default values were specified for hire date, the column is assigned to the, well, we know that this is going to be the sysdate. If you don't have a default value, if no default value was specified when the column was created, so this is creating a column. Well, this is saying we had sysdate here when the table was created, but this last bullet point, if there was no default, then it would assign a null value. All right. So that's default. Default can be useful. I've used it always with hire date and whatever iteration of date when I was a DBA. All right, let's move on to merge. Using the merge statement accomplishes two tasks. At the same time, merge will insert and update simultaneously. And be very careful with this. If a value is missing, a new one is inserted. If a value exists but needs to be changed, merge will update it. So insert and update simultaneously. So to perform these kinds of changes to the database tables, you need to have insert and update. Well, you all do. And aliases can be used with the merge statement. So take a look at this merge syntax. Merge into destination table using source table on whatever matching condition, almost like a join. When matched, then update. You said this way. When not matched, then insert. So basically, when the condition is matched, etc. You can kind of read through this and see that it's either going to update or insert values. All right, let's look at an actual example. So if you look at this example, an employees table, which is this E, merge into this copy table using employees. So the syntax is merge using an employee ID equal, that's our condition. Employee ID from our copy table is the same as employee ID of our employees tables. When matched and update, set last name equal to last name, department ID is department. We're not matched, and we're going to insert the employee ID, last name, and department ID. So update and insert simultaneously. But there is a condition. So basically, if you have an issue with a copy table, or even correlate or related tables, you can run this merge command to update or insert data. All right. And you see here, if we ran that on, we don't have a copy employee table, we didn't create one, but well, if we ran that and we needed to ensure that the specific rows were copied, you see here the employees 100, 103 have matching rows, so basically they're just copying over it and update it, whereas 142 had no matching rows, so it was inserted. I mean, hopefully you can visualize that. The source table in this example is the employees table. The destination table is your copy number. All right. And here's the tables, kind of drawing it out so you can kind of see what was copied and why, or not copied, what was merged and why. So here's the employees table, here's the copy before the merge, and here's the copy after the merge command. Does that make sense to everyone? Sort of. Right. Hopefully I'm not putting you all to sleep. All right. Let's continue. That was the merge. This is the multi-table inserts. So multi-table inserts are used when the same source data should be inserted into more than one target table. More than one target table. This functionality is useful when you're working in a data warehouse. So this is huge amounts of data, where it's common to regularly move data from the operational system into data where, yeah, basically if you want to copy large amount of data, you'd use a multi-table insert. Creating and managing data warehouse is one way of managing the sometimes very high number of rows. And that's generally how this is used. Imagine, for instance, how many rows of data your telephone provides. So it's a lot of records. So setting the context here, basically, you generally don't want to run a multi-table insert unless you're dealing with lots and lots of data. So multi-table inserts can be unconditional or conditional. In my experience, it was always conditional because I would not allow any type of unconditional DML to run. In a conditional multi-table, you can specify either all or first. So that's the key here. You can have this specification, which makes your life easier. Specifying all, if you specify all the default value and the database values, each when clause, regardless of the results, many and other when. So basically, it copies everything. For each when clause, those whose conditions evaluate to true, the database executes the corresponding into. If you use the first specification, the database evaluates each when clause in the order in which it happens or appears in the statement. For the first when clause, it evaluates to true the database. So this can be very convoluted, but I mean, it's probably best to see how to run a multi-table insert. So I'm going to skip to the, let you look at the syntax. The syntax, insert all into clause, and then values clause subquery. So insert all into my employees, values, hire date, first name, last name, into this is a copy of the table values, hire date, first name, last name. and then basically select your hire date, first name, last name from employees, which is a subquery. So insert all into, so we're basically building these tables from our employees table, the my employees and copy of my employees. And you can kind of visualize how that could be useful if you have a large amount of data and even several tables that you need to update, depending upon how it's used. All right, so take a look at this. I mean, it's a little hard to read. I need to clean that up a little bit. But primarily, insert all when called format in these particular values, then into all calls, which is another table, values, caller ID, calls, timestamp, call duration, when call format in. So yeah, I'll have to clean this up so it makes more sense. So I won't go through all of these, but there's several scenarios for depending upon the table. Just think of this as the same with the when and the then and the table names. It's like a multi-table well, it's exactly a multi-table insert. All right. So if you get to run some of those in your demo, so please do. That's really hard to weed through. I keep telling myself I need to clean that up, and I always forget to. But yeah, but it's better to run through these. Maybe well, I guess one of these sessions I'll create one of those complex queries, and we can walk through it. All right, for this topic 3, our terminology, default values, merge, multi-table inserts, all first and else. All right. Okay, so that's the topics of section 12. As usual, you probably have questions that you're not asking, but I do want to go briefly over this document that has certain commands for the certain types of SQL from DDL, which is what I don't know if you remember this, or maybe we didn't. We'll get to DDL. This is basically impacting the table or attribute. So create, alter, drop, truncate, rename. That's all table level. Think of it that way. And then DML is all data level as far as manipulation, which is what it is. DML, data manipulation. This is your select. As a part of that, your insert, your update, delete. And then DCL, we won't go into this too much because this is primarily dependent upon users, and you probably won't need, well, you don't need to worry about that in this class. Primarily DDL and DML. They'll talk about DCL a little bit, but as a matter of fact, we will cover granting privileges and all that, but that's the security base or the control language is what that refers to. And then TCL is your transaction control, your commit, your say point rollback, and you should have some intuition about what that does. Commit basically saves your word, say point, identifies a point where basically your transaction can be rolled back to, and then roll back, restores the database to the original since the last commit. And we will talk about those a little bit, but I do want to introduce those. We primarily went through the DML today. We're going to talk about the DDL later, and the DCL, TCL we'll also refer to as we finish up this course. But review those. You can research them. You can ask me questions if you need to, but primary for this class, we are going to stick with DML and DDL for the most part. All right. Then you also have your typical video resources, how to insert data into tables using SQL Developer. And that's a pretty good video. And then another inserting data, how to update data in SQL, and then deleting data. Remember, update, delete, make sure, use your where clause. There's a multi-table insert video and lesson. You can click on that and go into there. There's a lot of a lot of little things that you can learn about multi-table inserts, and have some clean examples in here too, much better than I showed you on the lecture. So that's just a link at the very bottom. It just takes you into a page where there's very, very valuable lessons if you need to go through those. If you go through those, remember this schema is very different than ours, so you'll have to change if you're going to run any of these examples to the appropriate data to see if that works. Maybe I should do that at one point. All right, so that's more of the resources for this section, and then you have your demo, which has another pretty good list of commands to help you understand DML, or even understand all the commands, DDL, DML, DCL, TCL. Gives you another part of definition, and then goes through some of these queries. All of these are associated with our schema, so you can run all of these. As I do want to suggest, going to these DMLs will actually change your data. And it's not a big deal unless you delete some of the tables, which hopefully you won't do that. But if you ever delete any of the tables, just go back to that original query that we ran at the beginning of the class, beginning of the semester. It'll restore the data to where it was. You can try and run a commit and rollback, but that's the easiest way to restore the data to where it should be as far as start. All right. So that's the demo. There's plenty of good queries in here. There's some that I did cross out because they are not associated with our schema no longer, so don't try and run those. But the rest are the ones that I've saved in here. I mean, you can run those. They're all associated with our schema. You'll check those. All right, and then you have plenty of practice. Make sure you go through this. Insert statement, and then the update. So try and solve it, etc. Remember, these are very good practice to get you set for the final, as you all noted as far as the midterm. So yes, make sure you go through the practice thoroughly, and then we have the solution. So no excuse. And then we have the section 12 assignment. And basically, it's pretty straightforward. Just 6 questions, pretty easy actually. So you shouldn't sweat over that too much. And then the quiz for section 12. Okay. Any questions about our journey into DML? Just sharing. You're all pretty quiet this evening. Is there a particular reason for that, or it's just we're just waiting for the semester to end? All right. Well, that being said, that's all I have for this evening. Almost everyone is here. Thank you for joining. Those of you that were later, I will post a recording. So if you need to catch anything that I did earlier, and let me remind you again, if you were not here early, we're not meeting next week. It's Veterans Day. It's my day off, and I'm going to sit at home and avoid people so they're not. No, but we're not meeting next week, and you don't have any assignments due next week either. So we'll meet again on the 18th, and we'll start with section 13 and 14. So you all take care, and I'll see you in 2 weeks.
Thank you, Professor.
Welcome. And I'm going to stop the recording.
Thank you, sir.
Yep.